Hi, in this video we are going to discuss two main pre-processing techniques like normalization and standardization. These two techniques especially is useful when we are using the models like KNN, SVM and the logistic regression because they are mostly based distance based approaches they are using. At the time when we are using the distance based models, it is good to use a normalization and or standardization any one of these techniques. Okay, by using any one of these techniques we can improve the performance. What is the basic problem with the distance based approaches? Let's see that thing. We have the models like KNN. Suppose consider KNN logistic regression and SVM. Let's consider data was look like the future F1 and F2. Two futures are there and the values look like this 2 7 5 3, and the F2 future the values like in hundreds, 100, 300, 500, 200. Let's consider this is a like lower values, it's like 1 200 these values like, but these values very huge from hundreds in the range. Okay, when you're finding the distance based approaches for the points, this is the point x1 point, this is the x2 point, this is the x3 point, x4 points. Okay, when you finding the distance between the points from one point to another point, because of the ranges are different for the future one and future two, we are going to get into a problem. Okay, to avoid this problem we are going to use the normalization and standardization. To limit the range, of the features we are going to use the one of these technique, normalization or standardization. By using the normalization technique we will limit the value from 0 to 1. By using standardization technique we are going to limit value from -1 to 1. Okay, let's some deep dive into these two techniques. First start with the normalization. We represent the data in a matrix form. In the data we have the features f1 f2, like this we have d number of features, that is a d dimensional, and the number of points in the data, let's consider the n number of points. For suppose the feature fj we want to normalize. Okay, we'll do only column normalization, we won't do the row normalization. Okay, by doing the column normalization, suppose if you want to do the normalization on fj feature, this is the values are in the fj features. Let's rewrite this one. Fj feature contain the values. For fj feature we have the values a1 a2 an values, and for this in the first step we are going to find the minimum, a minimum value. A minimum is equal to the minimum in the values a1 a2 a, and similarly we are going to find the maximum value, max of a1 a2 a. By this way we will find the minimum value in this column and maximum value in this column. We have the values, original values, these are the original values, and we will, by the normalization we convert these values like this. ai, for suppose we will consider ai bar equal to a is the actual value minus a minimum, the minimum value that we are get here, by a max minus a minimum. By doing this we will get the values like a1 bar for the future fj, we'll get a1 bar, a2 bar and an bar. These are values get by the normalization. and the range of these values will be 0 to 1. Let us check this one also. For suppose, let's consider the minimum value will be a minimum. When you consider ai ai is a minimum, at that time ai bar is equal to a min minus a min by a max minus a min. Here numerator is going to be 0, anything 0 by anything is going to be 0. ai bar we are going to get 0. This is the lower limit. Okay, and similarly for ai equal to a max, the maximum value in this data, that time the numerator and denominator is going to be equal a max a min by a max minus a min. Numerator and denominator are going to be equal, then we will get the value of 1. For the a minimum we are getting the 0. For the a maximum we are going to get the value of 1. By this way we are limiting the value of from 0 to 1. Now let us see how the standardization work. Like normalization, the standardization is another approach to preprocess the data. Here also we will consider the data is on matrix form and the features from f1 to the fd. That means d number of features are there and the n number of points are there. And for the fj feature we have the values. These are the values. Okay. Here also we will do the column standardization. We are not going to do the row standardization. Okay. And the values are fj contain the values a1 a2 a. These are the original values. In the standardization, first step we are going to find the mean of the features and the standard deviation. Then we will standardize the values. Okay. First step is we are going to find the mean. A bar, let's consider mean, the mean of the values a1 a2 an. Now we are going to find the standard deviation STD of the values a1 a2 an. Now we will convert this by the standardization. ai dash equal to ai is the original value minus mean of the feature, then by standardization. By doing this one we'll get the values from -1 to okay, and it is in the normal distribution. The data also in normal distribution. If it is any distribution, we convert the data into normal distribution by using the standardization, and the value lies between the -1 to 1. And if we want to do inverse standardization, we can easily convert by doing the inverse standardization. ai bar into s plus a bar, we will get the original value here. By doing the inverse standardization, we will get this value, original value. By doing standardization, we will get the value from the -1 to 1. By doing standardization, you will get the feature values a1 bar, a2 bar, n bar by standardization. Now let's some graphical geometric approach how the data was look like. Let's see that thing also. Let us consider in the data we have two features only, f1 f2. Here we can observe This is the actual data, and the features f1 and f2. Let's consider the feature maximum value is going to be 500, and the f1 feature, let's 7 is the maximum value. Okay, by this way actual data was look like this. By doing the normalization, in the normalization we are going to limit the data between 0 to 1. By doing normalization we are convert this data like this. And then for the standardization we limit the value from -1 to 1. If we apply the standardization technique on this data, we will get the like this. And here the range between -1 to 1, and the distribution also is a normal distribution. Normal distribution. These are the two most important pre-processing techniques we are going to use before the modeling, especially when we are using the distance based approaches like Kane and logistic regression SVM, and also we are going to use before the applying the deep learning models. Also it is very important to apply the normalization or standardization before applying the deep learning models.